So let's see. Today's topic, we will start to see what it's called linear equations with one variable. In this case, we will see first all the theoretical stuff about linear equations, also about equations, because it's the first equation we are going to see on this topic. So let's see. First, we need to know what is an equation. Well, equation comes from the word equality. That means something that it is equals to another stuff. So we can also define an equation as two equivalent algebraic expressions. It's very important here to differentiate between having two equivalent algebraic expressions and equivalent equations, because having two equivalent algebraic expressions means we have one algebraic expression on the left that it's equivalent to another algebraic expression to the right. But in the case of equivalent equations, they have either a common divisor, or also we can see it as they are multiplied by a common factor. So in this case, 5x squared equals 25 and x squared equals 5, they are both equivalent equations. Why? Because if we multiply all this equation by 5, then we will get 5x squared equals 25. If we divide this expression by 5, then I will get x squared equals to 5. So that's very important. Don't get confused between two equivalent algebraic expressions, that means one on the left, one on the right, and two equivalent equations. That means we have two equations that they have either a common divisor or multiplied by a common factor. So let's see, here we have that the left part of the equation is called normally the first member of the equation, and the second part of the equation, the right part, it's called the second member of the equation. And of course, on the middle we have the equal sign. In equation we got variables, that means letters with unknown value until solving, and constant or numerical values that do not change. That mean numerical values or numbers that can be either whole numbers, integers, or also fractions. So let's see, what about solving a linear equation? If we want to solve a linear equation, normally we need to change members from the first to the second, and also some values from the second to the first member. So how to do it? If the terms change from one member to another, we need to use the opposite mathematical operation. That means if a term it's positive or plus on a member and it changes to the other one, it will be a negative one. It also applies for the negative. If we have a negative one in one member and we change it to the other member, it will become positive. If something is multiplying on the first member, it will become a division on the second member, or vice versa. Solving a linear equation, it's also called isolation of a variable. Let's see about types of equations and the degree of an equation. So types of equations, there are many kinds. We are talking about 4 of them. The first one is the numerical equation. That means we don't have letters. In this case, we only have numbers. In this case, 5 plus 3 equals to 8. A literal equation, that means it will have letters or variables that represent known values. In this case, 2x plus 3 equals to 5. Then we can have also whole equations. That means we will only have whole integer numbers, can be positive or negative, like this one, 3x plus 5 equals 2x minus 3. And we also have what it's called fractionary equations, in these ones, denominator is different than 1. That will mean we will have fractions on the equation. Let's see about the degree of an equation. The degree of an equation depends on the highest exponent value in the unknown variable. So the highest exponent that our variable has, that will tell us which type of degree of an equation we have. The first degree, we will have only x, and it's also called the linear equation. The second degree equation, we will have x squared or either any letter to the second power, and it will be called quadratic equation. And if we have an exponent that it's number 3, it will be a third degree equation, and it's also called a cubic equation. It's very important that the degree of an equation will also tell us the number of solutions we will get. If we get a first degree equation, we will have only one answer or one solution. If we have a second degree equation, that means we will have two answers for our equation. And if we get a third or a cubic equation, that means we will have three answers for that specific equation. So let's go to another information about linear equations with one variable, and we will start seeing how to solve a whole linear equation with one variable. So let's see another little information about linear equations. The answer of an equation, it is always called, or sometimes it's called, the root of the equation, or also the solution of the equation. Either of the names, it's correct. We can call it the root of an equation or also the solution of an equation. Here we have a little information. It's more convenient to have like the letter equals the answer than answer equals the letter. I mean, both of them are mathematically correct, but this one is so more used that we will use only this one, please. Don't use answer equals to x when solving an equation. Always put the variable equals the answer. So let's see about whole linear equations with one variable. It says to solve, send the variables to the first member. That means the variables or the letters will go to the left, and the constants to the second member. That means the numbers will go to the right of the equations. It is very important, this part. When we get the answer or the root or the solution of the equation, we can verify if that answer is correct. How we will do that verification? Once we have the value of the literal letter, we replace the letters with the numerical answer on the original equation. So we will need to do that verification when asked. We will need to replace the letter or the variable with the numerical value we have on the solution and check in the original equation. That's very important. The verification process, we will do it always on the original equation. So we will see how to solve and how to verify the root or the solution of a whole linear equation with one variable. So let's see some examples. So let's see, on the first example, we have something like this. We have a linear equation. So it says that to solve, we need to send the variables to the first member, that means to the left, and the numbers to the second or the right member of the equation. That will mean we will start with the letters. That will mean we will have the equal sign. We will put the letters in the first member of the equation, that means 3x is positive. It doesn't move because it's on the left part. The 6x, it's also on the left part of the equation. The plus 17x will change to the first member of the equation. Remember, if we change a term to another member of the equation, we need to do it with the opposite operation. In this case, plus. It will become a minus. And this plus x will change also to the left. It will become minus x. And then we will do the same with the numbers. Of course, we have this 6, this 15, and this minus 7, that they do not change from member because they are on the right part. The ones that are going to change member are this plus 3 will become minus 3. This plus 2 will become minus 2. And this plus 6, it will become a minus 6. So then we can do like term simplification. On the left part, we have 3x plus 6x. It's 9x. So we will have 9x. The negative ones, it's going to be 18x. On the right part of the equation, we will have 6 minus 6. It's 0. Then it's going to be 15 minus 7 minus 3 minus 2. It's minus 12. Of course, you can do this part by mind, but I'm doing it with steps because of explanation purposes. 9x minus 18x, it's going to be minus 9x equals 3. Then we need to isolate the x because we need to have the value of x. This minus 9, it's multiplying the x. That means if we change it to the other part of the equation, it will be, if it's multiplying, it will go dividing. So we will get x equals 3 over minus 9. So in this case, it will be 3 over 9. We can simplify it. Remember, in every topic, if it's possible, we need to simplify it. So our answer will be x equals, in this case, we can put the minus sign in the outside part of the fraction. 3 over 9, they can get divided by 3, and it's going to be 1 over 3. So our answer is going to be x equals minus 1/3. So that's how we solve this specific exercise. Let's see how to verify. So remember the verification process. In the verification process, we need to use the original equation and use the value that we have on the answer. So in this case, the original expression is 6 plus 3 that multiplies minus 1/3 plus 2 plus 6 that multiplies minus 1/3 plus 3 equals 6 plus 17 that multiplies minus 1/3 plus 15 plus, it will be minus 1/3 minus 7. So let's see, in this part we will get 6. It will be 3 that multiplies minus 1/3. 3 and 3 will eliminate, so it's going to be minus 1. Then it's going to be plus 2 plus, it's going to be 6 that multiplies minus 1/3. So in this case, if I multiply 6 by minus 1/3, we will get minus 6 over 3, it's 2. So it's going to be minus 2 plus 3 equals, it's going to be 6 17 that multiplies minus 1/3 is going to be minus 17/3 plus 15 minus 1/3 minus 7. So let's see. On the left part of the verification process, it's going to be 2 minus 2, it gets eliminated. So it's going to be 6 plus 3, it's 9, minus 1, it's going to be 8. In the right part of the equation, it's going to be 6, in this case, minus 17/3 minus 1/3. It's going to be minus 18 over 3 plus 15 minus 7. So in this case, it's going to be 8 equals 6 minus 6 plus 15 minus 7. 6 minus 6 disappears. It's going to be 8 equals 15 minus 7, it's 8. 8 equals to 8. So yes, now I have solved the equation, and I have also verified that my answer is the correct solution or correct root of that specific whole linear equation. I know that the verification process is maybe a little bit long, so it's sometimes we don't use to do the verification process, but if the teacher asks you to do the verification process, you will need to do it in the original equation as we do it on exercise 1. So let's see another example. So let's see, in this second exercise, we have an equation like that. At the beginning, it looks like it's not a linear equation. Why? Because the n squared have an exponent of 2. So it seems like this one is a quadratic or second degree equation. But we will see that when we get the variables in the first member of the equation, all those that have the second power will disappear, and this specific equation will be a whole linear equation. So that's very important. We first need to check out if the letters do not disappear between themselves, and this equation will be a linear one and not a second degree equation. So let's see how to solve it. So it says we need to put all the variables on the left, that means on the first member of the equation, and the numbers on the right. So we will start with the n squared, 2n, and 3n squared. So we have the n squared and the plus 2n squared that do not move because they are on the first member of the equation. The 3n squared will move, so it's positive, it will be negative. Then we go with the n, so we have 5n that doesn't move, so it will stay here. And we have also plus 3n that will become minus 3n. And we have this plus 2n that will become minus 2n. So what happens here? This one will have the numbers. We have the minus 13, the minus 5, and the minus 5. So it will be the minus 5 that doesn't move. Then minus 13 will become plus 13. The another minus 5, because it changes from the left to the right, it will become plus 5. This minus 5 and this plus 5 can disappear. It will be the same here because n squared plus 2n squared is 3n squared. So they disappear. And here we will have 5 minus 3 minus 2, it's 0n equals 13. Here we will have something specifically. 0 multiplied by any number, it will be 0. So it's impossible for n to have a specific value. Why? Because we cannot find any number that multiplies by 0 will get us 13. Also, if we do it like the 0 is multiplying the n, we can send the dividing, but the division by 0, it's not possible. So what do we do in this case? In this case, because 0 it's different than 13, in this case we can put either by text that it's we don't have not a solution, that we don't have a solution, we can put it in text, we don't have a solution, or we can put also in this case that n is an empty, that means an empty space, that there is no a solution for n. So we can put either by text that there is no a solution for this equation, or we can put it mathematically that n it's an empty space that doesn't have a specific value. Or of course, in this case, it's impossible to do the verification process since we don't have an answer. So in this case, my recommendation is if we get something like this, we check our process to see if we have made a mistake. If not, then our answer is the problem doesn't have a solution, or the equation doesn't have a root or solution, or the solution it's an empty space that doesn't have a specific value. So let's see another example. So the third exercise will be something like this. We have w plus 5 and we have two different algebraic expressions in an equation. So let's see, in this case, remember the variables will go to the first member, that means to the left. Those that doesn't move, they stay like they are, w minus 3w. Minus 2w will change because it changes from the right member to the left one, so it become, we have minus, it will become plus 2w. And what happens on the right, we have the 12 that doesn't move, the plus 7 will become minus 7, the plus 5 will become minus 5. So in this case we have w plus 2w is 3 minus 3 it's 0, w equals to 0. That means every number that multiplies 0, it's 0. 0 equals to 0. So this one it's a little bit different than the number 2, because on the number 2 it was impossible to find an answer. But in this case, every number that we put on the w, it will become 0, because 0 multiplied by everything, it's 0. So in this case, we can put the answer in very different ways. Why? Because in this case, it will be w that it's 0 over 0. We can put either that it's undetermined, I mean, not indeterminate, it's undetermined. We can put it in text. We can put infinite solutions. So we can put it, this specific exercise has infinite solutions. Or we can also put it in a mathematical way, that it's, in this case, w, it's part of all the real numbers. Why all the real numbers? Because if we put every number in this equation, supposedly we will have a correct answer. Why? Because we have seen here 0 multiplied by every number, it will be 0. That's why this specific equation has infinite solutions, or we can say it like the letter, in this case w, has, or it's on the part of all the real numbers. That means the space of W, it's all the real numbers. So in this one, we can verify it, because if we said like every answer must be correct, it has an infinite solution, then we can do the verification process. So in this one, to do the verification process, it's going to be very easy. So we have, maybe we can use either number. I will use, I don't know, maybe I will put 5, because we can use every number we want. So the original expression is W, that it's going to be 5 plus 7 minus 3 that multiplies 5 plus 5 equals minus 2 that multiplies 5 plus 12. Remember, the verification process must be on the original expression. If not on the original expression, it can be incorrect. So in this case, it's going to be 5 plus 7 minus 15 plus 5 equals minus 10 plus 12. So in this case, it's going to be 2 on the right part of the equation. On the middle part, it's 17 minus 15, that it's going to be 2 equals 2. So that means is correct. So that's why in this case, we will have infinite solutions for our equations. So we have seen 3 different types of exercise. When the variable has a specific value, like exercise 1. In exercise 2, remember, we don't have a value for the letter, because it's impossible to something multiplied by 0. It's impossible to give us a number. So that's why the empty space. And in exercise number 3, in this case, every number multiplied by 0, it's 0. And that's why in this specific case, we have infinite solutions for this equation. So that will be the 3 different type of answers we can have in a linear equation with one variable. So I will do only one last example of a specific value of an equation. So in this case, we have this equation. So it's very easy. Remember, the letters will go to the left, or the variables will go to the left part of the equation. So those that doesn't move stay with the same sign. In this case, minus 11 minus 12n. The other one, minus 5, will become plus 5, because it changes from a member to another of the equation. The plus 6 is going to be minus 6n. What about the numbers? 17 and minus 2 and minus 10, they stayed in the same member of the equation, so they do not change sign. In this case, the minus 9 will become plus 9. The plus 8 will become minus 8. And let's see, in this case we have, so in this case it's going to be on the left part. Remember, you can do it by mind, but I will do it on steps because explanation purposes. We will get minus 11 minus 20 minus 12 minus 6. It's going to be minus 29n plus 5n equals, and this part is going to be the positive ones. It's going to be 17 plus 9. It's going to be 26. The negative ones is going to be minus 20. So in this part, it's going to be minus 24n equals to 6. So n will be 6. Remember, the minus 24, it's multiplying the n, so it's going to be dividing. 6 over minus 24, we can simplify it, so we can divide it by 6, and we can put it like minus on the outside part of the fraction. Divided by 6, it's going to be 1/4. So this answer is going to be n equals minus 1/4. So in this case, because we have a specific value of n, we need to do the verification process. I won't do the verification process because of the time. But remember, the verification process must be done on the original expression. We cannot do it here or here or here. We can do the verification process only on the original equation. As I was telling you, I won't do it because of the time, but when you are asked to check out or verify a specific solution of an equation, we need to do it on the original one. So that will be it for today's topic. That was whole linear equations with one variable and all the theoretical stuff about linear equations with one variable. We will see each other on the next class.